Thank you very much. Good day all. I hope you can see my first slide there.
You can?
Yeah.
Lovely. Okay, good morning. So my name's Guy Parker. I'm a director of Wychwood Biodiversity, which is a small consulting firm that's based in South Devon, but with consultants scattered around the UK. We specialize in renewable energy and biodiversity, particularly solar, but also wind, and looking at how the impacts of renewable energy installations can be minimized and how we can look for opportunities to improve these land holdings for biodiversity gain. So the topic of my talk today is opportunities and concerns for wildlife in relation to onshore wind turbines. So a bit of context. I think it's worth pointing out that, yes, we're in a climate crisis, but climate change is actually one of the most significant threats to biodiversity itself. And so climate change is contributing to the biodiversity crisis. And this is because rising global temperatures trigger more extreme weather, which tends to lead to degradation of ecosystems and habitats on land and in the sea. And that leads to the loss of wildlife and their habitats. I mean, a really good, simple example of this is butterflies tend to do very badly in the increasingly erratic summers we have with the big downpours of rain and so forth that we're all slowly getting accustomed to. Renewable energy generation is also generally seen to be contributing to conservation because it does help to protect wildlife. And it does tend to produce little or no pollution at the source. You'll see many wildlife conservation organizations like RSPB, like WWF being generally supportive of renewable energy projects as a result. I say generally supportive because there are, of course, impacts relating to renewable energy projects and wildlife, and that's really what we're going to look at today. But to help deal with those impacts, we do, of course, have a very clear planning system and a system of environmental impact assessment that each renewable energy project will have to go through. And there's a system which you'll all be familiar with, I'm sure, called the mitigation hierarchy, where first of all, you look to avoid impacts by the way you site your projects. Then you look to minimize impacts by clever technology often, or the design of the project. And then you try to compensate or offset for any residual impacts to wildlife. And this is enshrined in our planning law. And of course, very soon we'll all be committed to a minimum of 10% biodiversity net gain as well. I bring this up because I'll refer to this as we go through the opportunities and concerns. So when I'm looking at an onshore wind project, I'm thinking of four main components: the turbines themselves, a collector substation that takes the energy in, a network of access roads which are used for construction and operation, and then, of course, the high voltage power lines which take the power away to the grid. So this really leads to three concerns that I'm going to be looking at today. So first of all, we've got bird and bat collisions with turbine blades or potentially the transmission lines. We've got habitat loss through the clearance and the construction process and the operation process. So the structures that sit within the landscape. And then we've got bird and bat mortality through electrocution or collision with the distribution network, with the big cables. I'm actually going to focus on the first two because I think they relate specifically to onshore wind, whereas the other one is perhaps a more general problem that we have within the UK. So looking at bird strikes, first of all, the problem we're dealing with is birds flying into the turbine blades and either being seriously injured or killed. In the United States, if you look at this table at the bottom of this slide, the annual fatality for wind energy facilities is about 1.8, nearly 2 birds per megawatt. Or to look at it in a slightly different way, in South Africa and Canada, the fatality rate for birds is around 4.5 to 8 birds per turbine per year. So that's not inconsiderable numbers when you think of the number of turbines across a country. And it's for certain that poorly sited wind energy facilities will increase that risk of bird strikes as well. So for example, wind turbines that may be sited within migration routes of birds or on geographic features like big ridges where birds tend to soar can cause increased mortality if they're sited that way. It's not just numbers of birds, the diversity of birds is also quite wide that's affected by wind turbines. A study from South Africa indicated that around 130 species have been affected since records began, although the problem tends to be more focused on those bigger soaring birds like raptors, or as in this photo, the storks. Bat strikes, very similar picture. Bats basically having trouble detecting the big moving blades and either being hit directly or being affected by the pressure wave that follows the blade. A few stats from North America, where a lot of the work on bats and wind turbines has been done, indicate that it's mainly your open area species, your insectivorous bats that eat insects that fly higher and in wide open spaces that tend to get affected by the turbines. Which kind of makes sense. They don't fly in the forest or along river lines. They tend to be out in the wide open space. Low wind speeds and before or after passage of storm fronts tend to be areas when mortality for some reason is much higher with bats. And as for the birds, the risk to bats is not just from resident species that live within an area, but also those that may be migrating long distance too. My third concern that I'd like to raise quickly is physical habitat loss. So while the physical footprint of wind power turbines and access roads is usually relatively small, you've just got a small vertical structure with a relatively small footing. In combination, they take up quite a lot of land, as you can see in this photo, if they're a larger onshore wind farm. And then there'll be a network of all-weather roads between those turbines too, which will be there for the duration. So in combination, they have a fair footprint. They're often sited on upland areas where the wind speeds are higher. So the chance of damaging some of UK's more sensitive habitats is a bit higher. This includes deep peat bogs, which are a really important carbon store, as well as being a fantastic habitat for a whole range of biodiversity, from the very small through to some of our biggest raptors. There's evidence that some species avoid wind farms, resulting in displacement and effectively a loss of their habitat. Some work in Portugal resulted in black kites looking to avoid up to 15% of their range if there was a wind turbine or turbine array there. And so that previously used habitat was no longer used. And for some larger mammals, such as the European roe deer, the hare and the red fox, there's been some signs of avoidance too. So let's look at the other side of the coin now and look at what the opportunities are for onshore wind supporting wildlife conservation. The first thing to note is that bird and bat strikes can be greatly reduced if a project has been carefully designed. The first thing is avoidance, so appropriate siting and good design of the wind farm. And this can massively reduce the threat of a farm to birds. We need to use good information on bird territories and migratory patterns and so forth in order to make this an effective process. There's a very good example of this from Ben Anturick Wind Farm, which is the one in the photograph on the slide here, which is in northwest Scotland. This wind farm has a total capacity of 30 megawatts and was built in 2000. But prior to that, it was known that there was a golden eagle nest and a breeding pair quite close to the wind farm. And so they were monitored as part of the environmental impact assessment process by a woman called Sarah Rankin and a man called Peter Robson. They set up a long-term monitoring of the golden eagles. And as a result of their research, they basically moved the wind farm, Scottish Power Renewables moved the wind farm to the south and avoided the main territory of the of the eagles, and also committed to contributing to habitat restoration for the upland area around. The result is that about 1,700 hectares have been protected, and comprehensive monitoring of the eagles has continued since 2000. And there's been no problems, no issues of collision with the turbines, but also no change in the golden eagle's behavior as a result. So case studies, a good example of avoidance of impacts. Technology can be used to help avoid impacts for both birds and bats. There's some amazing new radar and camera systems which basically detect target species, and then a computer, I don't know how this works, but a piece of software will detect how far away they are, and then will slow the turbines if they come within a set distance. And this is both obviously reduces the threat to birds and bats, but also prevents having to shut down the turbines and stop generation as well. So it's a very clever system of minimizing impacts. Final point is coming back to the Ben and Turek case study. Sorry, Kayla.
No, just I'm conscious of time. So
yeah, is it okay? Yeah. So wind projects have a large land take and they generate significant funds over the life of the project. All new developments will soon require a minimum of 10% biodiversity net gain by law. And so we can use wind projects to help with upland restoration. I mean, bearing in mind that wind turbines tend to be set in upland settings, we could be looking at restoring peatlands and wetlands through de-wetting, repairing compaction, conservation grazing. And peat in good condition is not only excellent for wildlife, but also an excellent carbon sink. So in summary, I think onshore wind can present significant risks to biodiversity, but those most obvious risks in terms of bird and bat strikes can be well mitigated if the process of design is followed carefully and if we really understand the kinds of wildlife that are around. And there is this opportunity for large-scale landscape restoration that goes with the development too.
Thanks very much, Guy. And